Hello friends, let us now learn about the Heal effect. What is Heal effect? See, now the intensity of the X-ray beam which will leave the X-ray tube is not uniform. See, the X-rays which are produced do not have the same intensity. Why? Because the intensity of X-ray beam mainly depends upon the angle with which the X-rays are emitted. These X-rays are emitted in one angle, this at other angle, this is at other angle. This is the angle at which the X-rays are emitted. So, the intensity of this beam depends on the angle at which the X-rays are emitted. Next, one more important thing is that if you see this, if you draw a line which if you measure the intensity of X-rays and the angles, we will get this figure. According to this figure, if you see, this is the anode. See, here there is anode, here we will have cathode. So this is called as anode end of the X-ray tube, and this is called as cathode end of the X-ray tube. Now, when there is perpendicular, exactly perpendicular, this is the main. So, see, whenever the X-rays are emitted parallel to the anode surface. So, this is the anode surface. Whenever the X-rays are emitted parallel to the anode surface, there is decreased intensity of the X-ray beam is seen. Whenever the X-rays are emitted parallel to the anode surface, there is decreased intensity of X-ray beam is seen. The beam intensity is actually related to the angle of emission. If it is parallel, there is decreased beam intensity. The more perpendicular it is, there is increased beam intensity. And one more thing, the anode end and cathode end. At anode end and cathode end, there will be decreased beam intensity. And second, the intensity of exposure of the film is less at the anode end when compared to cathode end. At anode end, the intensity of film exposure is less than that of cathode end. Why? Because the anode end will absorb some of the X-rays to itself. Because the anode end will absorb some of the X-rays towards itself, the anode end will have lesser intensity when compared to the cathode end. Now, what does this Heal effect help tell us? What is its use? One, this Heal effect can be used to obtain balanced densities in the radiographs of body parts of different thickness. Meaning, if this is here, if you see here, there is more intensity. When compared to here, there is less intensity. So as a result, if you put thicker parts of the body towards the cathode and thinner parts of the body towards the anode, then obviously more intensity X-rays are required for thicker body parts and less intensity are required for thinner body parts. So this Heal effect can be used to our advantage. That means, for example, if you need to if you need to put thoracic spine AP view, the body is thick. Wherever the body is thick, that is at the abdomen side. Okay, thicker side, thicker body parts are placed towards the cathode end, whereas the thinner body parts are placed towards the anode end. By this way, the thicker body parts require more intensity. So as a result, these will get more intensity, whereas thinner body parts require less intensity. So these are getting less intensity. So as a result, this Heal effect will become less noticeable. Number two, we can also use we can also use a small amount of films of shorter size, lesser size. So that means smaller films. So if you use smaller films instead of using this big, see, if you try to put at this big film, so obviously there is difference in intensities at each point. So this will result in decreased difference in quality of X-rays at each point. So instead of this, if you use a smaller film, Smaller film meaning 85 to 104, where there is less difference when compared to 31 to 95. So smaller films, whenever we use smaller films, so on using smaller films will decrease the anode heel effect. Sorry, smaller films will decrease the heel effect. Number two, number three, one, using for thicker body parts placed over the cathode side and thinner body parts placed towards the anode side. Second, use of smaller films. Third, if the distance between the focus to film distance, this is the focal spot and this is the film. If the focal to film distance, this distance is made larger, then also the heel effect will be less noticeable. So by three ways, we can decrease the heel effect. Thank you.